So using what we have just figured out in part D, part E, so this part E, is asking to show that the magnetic field due to the proton at that point P, according to the Ampere-Maxwell equation, is the same as what we calculated in part A. So the Ampere-Maxwell equation is this part right here. So the current is 0. So we are looking for the part of the flux, not current, sorry, of the flux that is interesting us is the time derivative of the current. So let's do that first. So d flux over dt equals, almost everything is a constant again, except for t, so we'll take out the constants, 2 pi kqv times t over the square root of vt squared plus y squared. So this derivative, the time derivative, d over dt. So this derivative turns out to be y squared over y squared plus vt squared to the 3/2. So that is the evaluation of everything inside the brackets here. So I'm going to use this and rewrite the derivative of the flux with respect to time. So d flux over dt equals 2 pi kqv times y squared over y squared plus vt squared to the 3/2. So I'll make more room, sorry. So this is our, we don't need to do any more calculations on it. And then we have a mu naught and an epsilon naught multiplied by that. So an important thing also to note is that k equals 1 over 4 pi epsilon naught. So we'll make that substitution, and I'll rewrite this in a way that makes it easier to manipulate. So 2 pi, rewriting k as 1 over 4 pi epsilon naught over 4 pi epsilon naught times k, oops, I already wrote the k, times q v times y squared plus vt squared times y over the square root of y squared plus vt squared. So it's the same equation. The only differences are that I rewrote k as 1 over 4 pi epsilon naught, and I separated the y squared into a y here and a y there, and I broke the denominator into y plus vt squared to the first and y plus vt squared to the second. This is an important substitution or rearrangement that we can make, because if we remember our triangle from the first part, with this being the velocity of the proton, the y vt, and the square root of y squared plus vt squared. So y over y squared plus vt squared is the same as the sine of the angle between those. So we can rewrite this as sine of theta. So 2 pi qvy over, 4 pi epsilon naught times y squared plus vt squared, and then rewrite that as just the sine of theta. We multiply an epsilon naught times the time derivative, so I'll add an epsilon naught there, and then that cancels out with that, and then the 2 pi cancels out with the 4 pi, and we're left with 2 on the denominator. Rewriting that again gives us qvy sine theta over 2, and then this, again, using our triangle from before, is just the radius squared. So I'll rewrite that as r squared. And this, finally, times the mu naught, gives us the b dot ds. So, new part of the problem, b dot ds equals this, which is mu naught qv y sine theta over 2 r squared. Well, our ds is, if we remember, it is the, I'll draw it again, the Amperian loop here, if the field is perpendicular at every point along that Amperian loop, then it's just going to be the magnitude of B times the magnitude of ds. And the electric field, B is constant at a constant distance around the proton. So if point P was here, or here, or here, or here, it wouldn't matter as long as it was the same distance from the path. So B would be a constant, and then we'd be left with this. And then ds is simply bs, because we're taking the integral of the derivative of s. I guess you could think about it like that. So bs, and then s is the length. So ds represents the infinitesimal lengths along that ring. So s total would be just the length of the ring, which would be 2 pi y, if we remember what we're using, y to represent the radius of the ring, 2 pi y is the circumference. So I'll rewrite this and this over here. So b times the 2 pi y, and I hope this made sense, why I changed b dot ds to b times 2 pi y, equals mu naught qvy sine theta over 2r squared. If we let the y's cancel out, which is good because that means that it doesn't matter the size of the Amperian loop that we are choosing. So the y's cancel out, and we'll divide both sides by 2 pi, and we're left with the magnetic field equals mu naught qv sine theta over 2 pi times 2r squared gives us 4 pi r squared, which is the same answer that we got via Biot-Savart's law in part A, which is good. So check.